We're going to work on the section rational exponents today. You notice the numbering is a little different. I like to do that one after we get used to radicals a little bit, because radicals themselves are not hard, but when you throw fractions in there too, I think that makes it a little bit more difficult. Or maybe just a little bit scarier. So I saved this section until you were used to radicals a little bit. So a rational exponent is the same thing as a radical, and so this is Mod 3, homework 2, rational exponents. Right, and so if we have 9 to the 1/2, that is the same thing as doing square root of 9, which we can simplify. Your denominator is the index. All right, so you have to learn how to switch between these two types of notation. Then square root of 9 is 3. So we could simplify that. Right, the next one gives us a different root, 125 to the 1/3. So just switching. This time your index is a 3, so you have to write the 3. 2 is understood. So this will be the cube root of 125. You might remember that one is a perfect cube. It is a 5, or you could check it on your calculator. And so we had to tell it the root, cube root, second, and then the any root button, 125. Enter, 5. And we didn't check. Right, 32 to the 1/5 is 5th root of 32. So just getting used to switching your notation. 5th root of 32 you could do on your calculator. So I would have to put the 5 in first. Second, any root, so that's doing a 5th root. Some of the calculators are a little nicer. It will actually put the 5 right where the x is. 32, enter. And this is a 2. And we have one more for this question. So 64, negative 64. In parentheses, so the sign goes. It's a part of the radicand. So this one is going to be a cube root. It's okay to have a negative under a cube root, under any odd index. And this one is going to be equal to negative 4. Let's look at it on the calculator. So we're doing a cube root, so 3, second, any root. You're already under the radical, so it's okay just to put negative 64. It is under there. And the answer is negative 4. All right. So that's question 1. Question 2. This one I had to look closely. Because that question mark that's on the 16, I couldn't really tell what it was. So on question 2, it says 16 and it has a question mark. 16 to what power is equal 4. And the relationship here is that you need the square root. Square root of 16 is 4. So to write it with an exponent, that would be a half. So that would be our choice. And then we have the other piece of the fraction. We've had 1 in all of these so far. If you have this form with some other number in here, you have a choice of where that m can go. The denominator is always your index, and you can put the m on the inside here, or it works the same if you put the m on the outside of the whole thing. So it can be either way like this, whichever way it's easier to simplify it. And so this one, it is already in the radical form. It is in this second form that I wrote, and it wants you to go back to a rational exponent. So you have to watch your directions. So we have 4th root of x to the 13 is going to be x to the 13 over 14. Index is always the denominator. So for number 4, I have x to the 12 to the 1/4 equals x to what power? Right, so they want you to simplify this. And you have to remember your exponent rules. Power to a power, you're going to keep the base and multiply. Well, when you multiply 12 times 1/4, you can cancel, and you end up with 3. Or you could have multiplied across and reduced. So my a is going to be 3. This is going to equal x to the 3rd. They only want the a there. So question 5 says simplify this expression. This is also a power to a power. Right, and so your rule is going to be keep the base and multiply these exponents. So we have y, and we have 2/5 times 3/7. Multiplication is the place where you can cancel on your diagonals. Nothing cancels for us, so the rule is multiply across. So it will be 6 over 35. You can also do that math on your calculator. All right, let's see. Right with the positive exponent. So this should be our answer to this. Write the simplified expression using radical notation. So for this to be radical form now, to switch to radical form, the index would be 35, and underneath you would have y to the 6th. That is simplified. The exponent underneath cannot be as high or higher than the index. So you would want 35 copies. You only have 6. That's not enough to take any outside. There is another rule that comes up for simplifying, and I'm not sure where we hit it in this section. You are not allowed to have a common factor between the index and the exponent. If so, you would need to divide it out. It would reduce, but this one does not. So if that comes up in a problem, I will mention it to you guys. Right. The reason I paused a few minutes ago, I mentioned you could do that math on your calculator. This might be a section where you like to do it. And so if you wanted to just multiply fractions, so if you had trouble with fractions, this calculator does have a fraction button. Whoops. I have the mode switched on this one. Let me switch the mode back. All right, so now it will look like a fraction. The multi-view calculators will do that. All right, and so if I wanted to just do this math, the fraction math on the calculator, I would have 2, you have to go down, 5, you have to go out from under the fraction, times, fraction button again, and 3, down, and 7. And go to the end and enter, and it's going to give you a fraction. Let me see, if I was in the other mode, so that is how to do it if you have the multi-view calculator. Let me switch back, because our TI-30 calculators that are not multi-view, they don't have the nice fraction button. It looks like fraction button, but it's going to go in a different way. So you would put the 2 first, and then you hit the fraction button, and 5. And I would have to be careful here. Let me clear that out. I would need parentheses. You need parentheses around a whole fraction. So parentheses, I might be a little too conservative there. Let's see. If I use the fraction button, I'm probably okay. Parentheses are always your friend. So 2/5 times, and if I put the other one in parentheses, so the order you hit that fraction button, and some of the others it looks like a little backwards L where it's separating. So this one, it did give me that same answer. All right. So sorry, I sidetracked, but I thought about showing you that, and then I just kind of let it go. So now you have seen it on a calculator. This is the section you might like to calculate a little bit for your fractions. All right, so we're down to number 6. You have to remember here about negative exponents, and you will need to take care of that first. So you will need to switch this to the denominator to make it a positive exponent. And they want us to clean that up. Well, we're going to need to switch forms, so we're kind of going to ignore where it is. It's in the denominator. So we'll switch it to a radical, and the index is the denominator. Now, before you put the 4, you can choose for it to go inside or outside. If this is something you can simplify, which is a perfect cube, I would choose to put the 4 on the outside. All right? Cube root of 8 you can do on your calculator is a 2. So this is 2 to the 4th, which is 16. Now, don't forget we were just working on the denominator. So this is really 1 over 16. So if you have a negative exponent, switch that to the denominator so you have a positive exponent before you can really go into your other notation. All right, I'm going to skip 7. That's a positive exponent, and we have done some like that. So let's look at 8. 8 is another with a negative exponent. So we're going to switch to the denominator. So 1 over 27 to the positive 1/3. And then we can switch that to radical notation to possibly clean it up. So cube root of 27. and you can test that on your calculator. It is a perfect cube. Cube root of 27 is 3, so this simplifies to 1/3. When it's harder powers, we'll work them out, but I thought some of those first ones you might know. We'll get a new page here. You guys stop me if you have questions on anything. All right, so question 9, and we have 9 to the 3/2. Right, so if we switch the form, it says 9, and you're doing a square root, so you don't have to write the 2. Right, before I put the 3, I'm going to decide, can I evaluate square root of 9? Yes. So choose to put the 3 on the outside. Just makes it easier. So square root of 9 is 3, and then you have the 3 to the outside. 3 to the 3rd is 27. This one should be 27. Right, let's see. 27 over 8. And we have this one to the 2/3 power. All right, so that would be cube root of this. And then we're going to square the whole thing. So cube root of 27 over 8, and then we will square the whole thing. And the reason I chose that, these are perfect cubes. Sorry, my brain was running a little faster than I was explaining to you there. You would think about splitting it. So cube root of 27 and cube root of 8 is 3 over 2. So that takes care of the radical. I knew those two were perfect cubes, and so that is why I put that exponent on the outside. Most of the time, it will go on the outside to help you clean it up. And then if you aren't able to clean it up, you put it on the inside. So we would still need to work this out. A power on the outside, the parentheses, it will go to each one. So we're going to have 3 squared over 2 squared, which is 9 over 4. So we had to do a little work there. Right? And this one has negative 27 to the 2/3. Probably better get a new sheet here. So this is cube root of negative 27, which cube root is okay. 27 is the perfect cube. It's a 3. So we will put the 2 on the outside. Right, so cube root of negative 27, and you can test it on your calculator. So 3 second any root negative 27 is negative 3. Now, that is the answer that's in here. You want the whole thing to square, so you need to still have parentheses. And this will give you a positive 9. Whatever sign comes out of this is going to the power. So that's why the parentheses. Right, question 10 says, evaluate this without using a calculator. Enter your answer as a integer or reduced fraction. No decimals, D&E if it is not real. All right, so 16 to the negative 5/4. First thing is switch it and move it to the denominator because of that negative exponent. Right, and then you can put your radical on. So 1 over 4 through to 16. Test that, see if it's a perfect power. It is, so let's put the exponent on the outside. Right, and so we still have 1 in the numerator. 4 through to 16 is a 2. And 2 squared gives us 4. So this simplifies to 1, 4. Oh, wow, this is H. You know what I did? Okay. Here, I put a 2 there as if this were a 2. It should have been a 5. This should be a 5. So we'll go back and fix that. And 2 to the 5th, you can do it with your exponent button on your calculator, is 1 over 32. Sorry about that. All right, next one. So you have to remember your exponent rules here. When you have a fraction, you will keep the base and subtract exponents. And I would probably write that. We're going to do 4/5 minus 3/5. That kind of lets you put that much on paper. You've taken care of what the rule will be with the fractions, and then you can worry about doing it. If you add or subtract fractions, you have to make sure about a common denominator. We do have a common denominator, so we're going to keep it and combine the numerators. So we keep the 5, and 4 minus 3 is 1. You have to watch out how they ask for the answer here. It does not say anything, so I think that it would want the rational exponent. But it should accept either one if it doesn't tell us, right? Let's just play with this and see if it would take the cube root of, the 5th root of x. That's more work than you need, but we'll check it. No. So it wasn't specific. That is an equivalent answer. They should have said, write your answer with rational exponents. Okay, so we did it right. You don't have to switch back to the radical. Okay, number 12. Right, we have x to the 1/5 times x to the 1/3. Remember with your exponent rules, this is like bases multiplied. Your rule is keep the base, add the exponents. So I would write that much down, x to the 1/5 plus 1/3. Right? I'm going to show you this by hand, but we're also going to punch those in on the calculator. So the 1/5 plus 1/3. You have to get a common denominator here, but let's look at it on the calculator. So I took this one out of the mode. I took it out of the math view mode. So I think I have to do that first. Okay. I am switching modes there just to show how two different calculators view. If you just have the multi-view calculator and you have not switched the mode, you can go straight to this button first and it would look different than it's going in now. So 1/5, and this might not work out right. Let's see how it does. Oops, don't want that. All right. The safest way to put this in would have been parentheses. 5 plus 1 fraction bar 3. We'll see if it gives us the right answer. All right, I think it did. Parentheses would have just made me feel a little safer that it had all of 1/5 together and all of 1/3 together. and that it was not going to add the 5 plus 1. So you want to make sure that the calculator is doing what you think. All right, so let's do this by hand real quick. You would have to get a common denominator, and it would be a 15. So this one, to get 15, needs a 3, numerator and denominator. This one needs a 5, numerator and denominator. So then we end up with x to the 3/15 plus x to the 5/15 equals x to the 8/15, which is what we got on there. Good. All right. 13. We have 9x to the 5/11. They want us to switch it to radical form. What you have to remember is the exponent only goes with the piece it's right beside. To make it go to more, that you would need parentheses. So this exponent only goes to the x. So to write it with a radical, your 9 is outside, and your 11 is your index, x to the 5th. This is a place where I would put the 5 on the inside because you're not able to simplify 11th root of x. So just go ahead and put the 5 in there to make it a little bit cleaner. When we had numbers and we could do something else, we were putting it on the outside. So we're good there. Right, this is coming back to one we did earlier. We're the same type. It is a power to a power, and this is where you are going to multiply the exponents. So these are going to multiply. So 13 over 8 times 13. This is pretty big. Whoops, wrong calculator for you guys. So 13 over 8 times 13. And I'm getting 169 over 8. So that should be the A. So this should be x to the 169 over 8. Let's see about, whoops, sorry. $169/8. That's all they wanted, was the exponent in that question. So you really have to know your exponent rules to be able to work with this well, which you should at this point. All right, so we have x to the 77th over 128, and this is to the 2/7. All right. I think that we should probably take that exponent down first instead of writing this big thing as a radical. So let's take it to the numerator and the denominator. So this will be x to the 77th to the 2/7, and this will be 128 to the 2/7, which we might be able to work on. This one is a power to a power, so you're going to keep the base and multiply. So that is 77/1 times 2/7. Your 7 will go into 77 11 times. So 11 times 2 is 22. So we have x to the 22 over 128 to the 2/7. Let's see if we can simplify that radical. So 7th root of 128. We'll have to go to a calculator for that. Home calculator. Sorry, I should have turned that other one off. I had it with my other class. So 7th root, so 7 second any root of 128 is 2. All right, so we're going to be okay here. I'm just working on this denominator. So this is 2. So I can put the exponent of 2 on the outside. So this gives me 2. And then 2 squared is 4. So my simplified answer is x to the 22nd over 4. I'm going to turn this calculator off. All right, so x to the 22nd over 4. Good. All right, this next problem is one of the reasons we have rational exponents. So it is a multiplication of radicals, and if we did not know how to switch this to rational exponents, we could not do it, because to multiply, the index has to be the same. So we can switch it, and so this is x, right, and this is a square root, so that's the index. This is actually 6 over 3, which is 2, times, and this will be x to the 7/4. Right, your rule for like bases multiplied is keep the base and add. And then you would need this 2 to look like a fraction. They want the final answer, I think, with a fraction. Otherwise, you could do 2 and 7/4. Oh, you couldn't leave it like that because that's more than 1. All right, so let's write this as a fraction. You need a common denominator. A 4 will work. So this one is going to multiply by 4 over 4. The other one already has the 4. So that will be 8 over 4 plus 7 over 4. Gives us 15 over 4. Keep the denominator, combine the numerator. Great, and they say write the answer as a reduced fraction. So they only want the a for the exponent. They don't want the base there. So they want 15 over 4. So a equals 15 over 4. Okay, Mrs. H messed up the math. Right here on this radical. Sorry, guys. Okay, this was a square root, but 2 into 6 goes 3 times. It's okay to tell me if I do that. All right, which is going to change the rest of the math. This is a 3. You're still going to need the common denominator. So 3 times 4 is 12. And then 12 plus 7 is the 19. All right. So it's nice to have the answers. Sorry about that. I messed up right here. I was not careful. I was already thinking about the 3. But it was a square root. Write it down first. Okay. All right, and they really have these mixed. You get a problem that looks kind of easy, and then you can get one that looks really hard. This one looks really hard. So we should do it here rather than you have to do it on your own, right? Okay, so x to the 55, y to the negative 25 over 1024 to the 2/5. All right, and so if we take that down, it goes to the numerator and the denominator. And it will apply to each of those pieces. We can do it just to each one. So x to the 55 to the 2/5, and those are going to multiply. 55 over 1 times 2 over 5. And that will give us, the 5 will cancel into the 55 11 times. 11 times 2 is 22. So I have x to the 22. All right. Then let's do the y. It's okay that that's negative. I can work with it there, or I could have moved it, either one. Let's just leave it there for a minute. So negative 25, and that will be to the 2/5, which will also be a multiplication. So negative 25 over 1 times 2 over 5. The 5 will go into this 25 5 times. So this is going to give me y to the negative 10. All right, I just took care of the numerator there. And now I have 1024 to the 2/5. So let's see, 5th root of 1024. So we would try a calculator there. All right, so 5, second, any root, 1024 equals, and I expected that to work out. So this gives me a 4, and then I will raise it to my other power. This was to the 2/5. So 1024, 1024 to the 2/5. I did to the 5. We'll put the 2 outside. This is 4 squared is 16. Right, so that is my number piece. And then your final step would be, you're not allowed to leave that negative exponent. So you will need to shift that y down. So x squared over 16y to the 10th should be our answer. Very good. You guys do okay with that one? That's a tough one. Right, next one. X to the negative 7 over 10. They want us to switch it to radical form. First thing you have to do is you have to get out of that negative exponent. So you're going to have to switch it to the denominator before you can change to a radical. Right? And so that got rid of the negative exponent. And now we have the 10th root of x to the 7th. And they ask for radical form, so this is what I think they would want. Later on, they'll tell us we can't have a radical in the denominator, but they haven't told us that yet. So that is what they want for that answer. Right. 19. We have 2 to the 9/4 times 2 to the 3/8. Right? Think of these 2's as x's. And the rule would say keep the base and add the exponents. So keep the base, add the exponents. And then if you're adding fractions, you have to have a common denominator. So an 8 would work here. We need to get a 2 on this one. So we have 18/8 plus 3/8. And this gives us 2 to the 21, 2 to the 21/8. And I'm going to assume they want the answer like that, which they do. If you switched it to a radical, you would have to simplify it because 8 would be the index and you have more than 8 here. So, unless they ask you for a radical form in this section, I think they want the rational exponent. Right. Number 20. This is one that we could not do without rational exponents. So we have the square root of x divided by the 4th root of x. We can't divide them out, or we can't put them under the same radical because they have a different index. So we'll switch to rational exponents. This is x to the 1/2 over x to the 1/4. And then we can use our exponent rules and work this out. When you have a fraction of like bases, remember you're going to keep the base and subtract the exponents. And subtraction, like addition, needs a common denominator. 4 will work, so this one needs a 2. So I'm going to go back this way a little bit. So we have x to the 2/4 minus 1/4 gives us x to the, subtract the numerators, keep the denominator. And they tell us to state your answer using rational exponents. So there we go. Not as bad as it looked. All right, -9 in parentheses. All right, going to the -7/2 power. All right, so first of all, let's change this exponent to positive. Remember, we would switch to the denominator. That does not change the sign in here. It only changes the sign on your exponent. And then we'll switch to radical form to see if we can clean this up. And that is where you get in trouble here, because the 2 would mean do a square root, but you have a negative number under there. And you're not allowed to take a square root of a negative number, so it doesn't matter where your 7 goes. This one is going to be DNE. Does not exist. And it is because you have a negative under an even root. Right, this one. So, 22. We have 81/256. The whole thing is going to the 1/4. You could apply it to each one here and make your radicals, or we could just do a radical with the whole thing. Fourth root of 81 over 256, that's probably the easiest way to go. And then you'll make separate radicals. So fourth root of 81 over fourth root of 256. And we'll do our calculator. I know that 81 is a perfect power. All right, so 4 second any root 81. The answer is 3, so that is my numerator. And the fourth root, so we'll do 4 second power any root, sorry, not second power, to second function to make it do any root of 256. And that one is also a perfect power. So 3/4. Um, 23 is going to be the same way. Do a fifth root of the whole thing and then simplify. They should be perfect powers. So we'll skip that one. It's just like what we did. All right, 24. So we have the fourth root of 256 x squared, and they want us to put it in exponential form. All right, so that is 256 x squared to the 1/4. All right, and they will want the 256 to stay. If you did power to a power here, a product to a power, it goes to each one. The 256 is going to stay to the 1/4. On the x, you get x squared to the 1/4. This one is going to reduce, and this will give you 1/2. This will give you power to a power, keep the base, and multiply. So we actually have here 256 to the 1/4 and x to the 1/2. I'm not sure if they wanted you to do that much. That would make it easy. All right, yes, they wanted you to do that much, but they wanted you to do more than that. Because this should be a perfect fourth power. Right, so 4 second any power, 256. And so that is 4 x to the 1/2. And it says write in exponential form, so they wanted the exponent on there. All right, 25. Negative 256 to the 1/4. Now, something you have to look at very closely here, which goes back to exponents, is the negative does not get to go to the power unless it's in parentheses. If it was going to the power, this one would not be okay, because it would have an even index. But the negative is not going to the power because of no parentheses. So this one is going to be, right, we are writing it with radical notation. It is going to be a negative on the outside, fourth root of 256. And let's see, that one we just did, which is 4. So this is a negative 4. Don't know if that's what they want. Okay, they want the -4 on the next line. Okay, so first they're trying to see if you know what to do with that negative. It cannot go to the power because there's no parentheses around it. So it's going to just come down out in front. This is what they want for the first answer, and then simplify it. It simplifies because that's a perfect 4th power. And the negative I just brought down because it's outside. Right. 26 is, they're also checking the same thing here, but it has a negative exponent. This negative is not going to the power. Right, so this negative is here. This is going to be 1 over 36 to the 1/2. And that will simplify. That's the square root of 36, which will just give you 6. That would not have been okay if we had parentheses. So -1/6. Ooh, those look mean. All right, good thing we're almost to the end, huh? So 27. Simplify the following expression. Write your answer without radicals. Okay, so they probably want rational exponents then. We have 121 x to the 1/2, and then we have 4. And this 1/2 is outside the parentheses. Notice this other power is on the inside. So we have to be just a little careful with that. This 1/2 is going to go to both. And square root of 121 is a perfect power. Right, so this is 11. So 11 times the square root of x, but they want the answer without radicals. So this is going to be 11x to the 1/2. We were able to simplify the 121. Right? Now this is times 4x to the 5/7. Right? This is just like if you had 11x to the 3rd and 4x to the 5th. Right? The numbers outside are going to multiply. So we're going to get 44. You can rearrange it if you want. And then we'll do the variables. Let's just rearrange it. That'll be nice. So 44. We have x to the 1/2 times x to the 5/7. And the way that you multiply variables is keep the base and add. So we're going to do x to the 1/2 plus 5/7. And we're going to have to do some fraction math there. We need a common denominator. A 14 will work. So we need 7 over 7. And you can use your calculator. It's fine. Just make sure you get back a fraction. You want to make sure you're practicing with it. Right? This will be 7 over 14 plus 10 over 14. And that is going to give us, we'll keep the 44, x to the 17 over 14 should be our answer. Good. All right. So we have 28. So we have x to the 1/2, y to the 7/24. All of this is in fraction form. So we have x to the negative 7/6, y to the 3/8, and x to the 7/12. All right, so we'll work with the x's and y's separately. All right, and I am going to go ahead. I don't really like negative exponents, so I'm going to move that to the numerator. That will give me a positive exponent. I'm still going to have to deal with the x to the 12th, right? So I have x to the 7/6 times x to the 1/2, right? We are going to keep the base and add. Which means you need a common denominator. 6 will work. So I have x to the 7/6 plus 3/6, which gives me x to the 10/6 on the numerator. All right, I'm just working on the x's right now. X to the 7/12, right? These are like a fraction. Your rule is keep the base and subtract. So 10/6 minus 7/12. You have to have a common denominator. So we're going to need a 2 on here to make a 12. So we have x to the 20/12 minus 7/12. And that gives us x to the 13/12. That just took care of the x's. Okay. And that is on the numerator. All right, so then you have to do the y's. And you're going to keep the base and subtract exponents. And to subtract them, let's see if I can make this roll down a little bit. If so, 7/24 and 3/8. So y to the 7/24 minus 3/8. Right? Common denominator would be 24, so you need a 3 here. So 7/24 minus 9/24. And this is going to be y to the negative 2/24, right? Which they probably want us to change to y over 1/y to the 2/24. All right, so let's put that back. If we put it with our answer, it's going to look like this. That was a 2/24. 2/24, they're going to scream about that. I should reduce that to 1/2. So they're not going to be happy with that answer. That should reduce. So I'm going to have to come back down here and just reduce it. Equals 1/y to the 1/2. Okay, so y, gosh, Miss H, no. 2 will go into 24 12 times. 1/12, not 1/2. So y, 1/y to the 1/12 is what I think here, because I think they want you to reduce that. I need a whole board for that one. Hopefully I remembered all the pieces. Let's see what they say. 13/12 over y to the 1/12. That's kind of a mean problem, right? I don't know that I'm going to work all the rest of these. Let's see what, there's 2 more. Let's see what they look like. This first one, and I don't know if you get a different version of this, if this will always be a 1 outside. Having a 1 outside to the first power, you don't need that at all. We probably have time for one of these. The last one is going to be similar. So we'll do just one of them. So x to the negative 1/2, y to the negative 2/3, x to the 3/8, y to the negative 5/3, and x to the negative 3/2. And we're just going to eliminate the to the first power. All right. It depends on how you like to work with the exponent rules. You could keep the base and subtract top to bottom, but you got to watch your signs. I am going to instead move these ones with the negative exponents to the opposite place. So all three of those are going to change positions. Everything else will stay the same. Whoops. This one will also have to change. All right, so this one is going to stay the same. Everything else is going to switch. So x to the 3/8 stays the same. X to the 1/2 comes down. And x to the 3/2 goes up. These y's are going to switch. Y to the 5/3 now. And y to the 2/3. All right, at least they're going to give us a common denominator. The y's are going to be easy there. If you're looking ahead, you're going to keep the base and subtract, which will give us y to the 3/3, which is 1. So that's going to be y to the first. So let's see what we can do to the x's. We should first work out this denominator, and then we will have to subtract from the numerator. So these that are side by side, you're going to keep the base and add. Get a common denominator, so an 8 will work. So you have x to the 3/8 plus 4/8 is x to the 7/8. Right, that is for the denominator. So you have x to the 3/2 over x to the 7/8. Your rule is keep the base and subtract. You need a common denominator. So an 8 will work. This one needs a 4. So we have 12 over 8 minus 7 over 8 gives us x to the 5/8. Right, and thank heavens the y was nice. 5/3 minus 2/3. You keep the denominator. 5 minus 2 is 3. And we get y to the 3/3, which is y to the first. This should be the final answer to 29. Good. I don't think you have to write that y to the first. Okay. We're going to stop there. We're not going to do the other one. The other one's going to work the same way. You have 3 x's to deal with, and your y's are here. So just kind of separate them like we did. Right. You guys have an awesome day, and I will catch you on Thursday.